Hi everyone, thanks for joining us today to discuss Wi-Fi best practices for outdoor design applications. Today, both of our engineers will be discussing with you these best practices. We have Daniel Coxwara and Gabriel Reyes. On today's agenda, we'll be reviewing our partner program benefits. We'll be going over why following best practices is so important, reviewing some AP product selection to help you better understand the best products to your applications, product placement and settings within bridge mode, and other tips and tricks for the best performance. If you have any questions throughout the webinar, please ask them in the question box and we'll address all questions at the end. So I want to start with reviewing the partner benefits. As an elite dealer within Genius, you will not only have access to special pricing, deal registration, and a plethora of resources to help you better understand our products and services, but you also have access to our Easy Wi-Fi Planner, which is our license-free network design tool that really gives you the power to design your own networks, which will enhance this best practices webinar so you can take these best practices for outdoor design and put them into the Easy Wi-Fi Planner for better projects moving forward. So for the partner program, there are no monthly sales minimums to qualify, but you have access to all of these great benefits. If you have any questions on the partner program, please email partners@ingeniustech.com. So now to kick off the webinar, I'm going to pass the webinar over to our engineers.
Thanks, Amanda. Okay, so hello, this is Daniel and got Gabe here. Hi. All right, so first off, okay, so best practices, why the reason to follow best practices. Now, if you attended last month's webinar, it was kind of a joke. It's so your Wi-Fi doesn't suck, but okay, well, that's true, right? Well, to ensure best performance and long-term reliability. You know, if you don't follow best practices, sometimes you can get away with it. Meaning, like, if you don't set channels right, you may be okay for a bit, but then 3 months later, something else, you know, you set yourself up for potentially later on having to come back and fix it. So a lot of times, sometimes you could kind of get away with doing things not right initially, and it sort of works, and then later on it bites you in the butt. So, okay, now we're going to cover product selection. So one of the things that comes up, and and I covered this with the indoors, the outdoor stuff is, okay, we have a lot of different models. We do. Ingenious has a lot of different outdoor ones with all these different things. So some are 24-volt DC, proprietary PoE, and some use the standard 82.3 AF AT power for powering it, 48 volts DC. So depending on your application, you may want one or not care. Usually the 24-volt stuff's usually lower cost, typically, but the 48-volt stuff has the advantage of being powered directly off a network switch, right? A standard switch. PoE pass-through, we have a couple models that have PoE pass-through. Of course, those are the 48-volt ones that provide power in, or take power in, but also can pass through a secondary Ethernet port on the other side, which is cool. Some are single band, which for bridging, that could be totally fine, or even sometimes as an access point. And then some are dual band, 2.4 and 5 gigahertz. Some have, talking about outdoor, some have an IP rating of 55, which is still good outdoor rating. It's still water resistant and everything, but then there's a higher rating, like up to IP68, which is very high for very harsh environments, like a marina with salt water and things like that. Then some have the internal antennas, some have external antennas. And the big advantage of having external antennas could be that you may want to use the RF connectors and run a third-party antenna. So you have that choice. So depending on if you need to do that, you want to get the ones with external antennas. Some are obviously omnidirectional. Again, the external antenna ones are omni, or some are directional. If you're doing bridging, you'd go with directional. And sometimes you can go directional for even as an access point, depending on you want to create certain, like in a sense, sectorize your coverage. Some have more power than others. They're all pretty high power. Some are a little lower, like down to 23, and some go as high as 29 dBm. as an access point, this is pretty much not an issue. In other words, as an AP, you never really want to be above 23 anyway. But for bridging, it could be useful. For example, we have some that have relatively low gain antennas, but can go really high power. That could be useful in some cases. And then some of the products we still have are some are N, and that means that the N models have a 10100 port Ethernet, so you're bottlenecked by your Ethernet. Those are a lower price point. So if you don't care, you're just doing a basic bridge, and you just need a couple megabits. You just got a little 2 megapixel camera. Doesn't even matter. But high throughput, high capacity AC and a gigabit Ethernet port is more what you want if you're going that direction. Important to point out, if you're getting an outdoor AP from Ingenius, doesn't matter which model, which one you're buying, it comes with a PoE injector. That might mean a 24-volt proprietary PoE injector, or if the model takes a 48, it's a 48-volt PoE injector. Whatever it takes to power the device, it's included. The N-Turbo and EWS models can be standalone or managed. That's the same, but when you put them in bridge mode, you cannot it doesn't manage bridge mode. So in a sense, when you change it to bridge mode or standalone, I should say that bridge mode is within standalone mode in even the EWS product line. Like, so for example, EWS 860, that 5 gigahertz radio, if you wanted it to be a bridge, you have to put it in standalone mode, and therefore it's no longer to be manageable. So just want to point that out so you know. Okay, so here's a slide showing a lot of APs. So kind of pointing out, okay, so the 871, that's the latest Wave 2 4x4 outdoor AP, high IP rating, IP67. The 870 is kind of the same thing, but with internal antennas. The 860, okay, that's a 3x3 Wave 1, okay. All those are 48 volts. They have PoE pass-through. You'll see the, actually the slide there, the peak usage. You'll see 21 watts without PSE, meaning if you're not powering the PoE pass-through with a secondary device, so the total could actually exceed the 30 watts. So you'd probably want to use our supplied PoE injector, actually, if you're powering, say, something else that requires secondary power, like a camera or something. The 860 is actually the same as the 870 and 871. That's actually a little correction in there. 660 is similar to the well, as far as 3x3, but doesn't have internal antennas. And you'll see usually the price points are reflective of that. One of the ones I think we do really well in, and it's a very aggressively priced, is ENS 620. Okay, the ENS 620, I like that model a lot. That one does, though, take 24 volts PoE, so it doesn't have the 48, but at the price point, being a Wave 2, 2x2, dual band, access point bridge, that thing is just, it's pretty awesome. And then we're coming out actually very soon with the ENH 1350. So it's actually kind of similar to the 620 as far as its capability, but the big difference between them two that I think that stands out would be that the IP67 rating. So the 620 is 55, but the 1350 is 67. I don't know why it's not there, it's just dash, but it's 55. Gabe, can you think of anything else in there that I'm missing you want to point out?
For these, I like to use 870s in parking garages because it's similar to 871. So it has internal antennas, no one gets to mess with it. It's really good for the high density, also for the use case on those. And then the 620, I do agree, is a good value, and so is the ENH 1350 EXT as well.
Yeah.
So the EXT 1350 would be a higher IP rating than the 620, and a little bit lower output power to handle for those for clients.
Yeah. And the ENS 500 EXT, super cost effective, just point to point. You could do a point to point bridge super cheap, like a point to point link, a couple 100 feet or something. Just what do you want to do? Just get a camera or something linked. Great product for that, doing something like that.
Or very high gain antenna. It's a very good one for a very high gain antenna. If you're going to pair it up with a high gain antenna. Yeah,
so this is an Omni, so it could act as like a root bridge, and then you got a couple directionals pointing back at it. We'll talk about that. Okay, now here's for bridges. kind of, because they're directional, like the End Station AC and End Station 5 AC, they're directional, like 19 dBi. So they're not super directional, but they're pretty directional. Okay, I mean, for the most part, the direction you're pointed is the direction you're getting. You can certainly get off to the side or do point to multi-point if you're close. These actually can go several miles point to point. And if you're off to the side, you could be a couple 100 feet off to the side or not even within the beam heading and still do a point to multi-point link. I think that's a misnomer. A lot of people overlook is the fact that you can be really close to these. And I did one where I was directly behind one, about 100 feet, is really close, but then the other one was pointed, a quarter mile down the way. So End Station AC is special, that has PoE pass-through. It's really, we do very well with this model in security. So with cameras, you can power up a secondary device because of the PoE pass-through. It powers up to 15.4 watts or 802.3 AF power on the secondary Ethernet port, gigabit on the other side of it, which is cool. And it comes with the PoE injector. So in a sense, you're not needing a PoE injector for your camera because we're kind of providing that with our device. That's kind of a way of looking at it.
Yeah.
You could also power it off a switch port. So you could even monitor on a switch, your power of the draw of both devices. 26 dBm, so pretty good high output power. It could act as a bridge or even as an access point. It can choose access point, but it's rarely used like that. The End Station 5 AC is Wave 2. I'd say it is 24 volts, though it doesn't have the PoE pass-through. I don't know what else to add to that. The 500 AC is directional, 14 dBi. That one's a nice one too. Very aggressively priced. The 202, okay, that's 2.4 gigahertz. So that one a lot of times is used as just an access point. A lot of times just to get coverage. You could do bridging, although what we'll talk about, we don't recommend, this is a best practice webinar, we don't recommend doing bridging on 2.4 gigahertz. Yes, 2.4 technically propagates better or further, but when you're bridging, you could make up for that and more with antenna gain, and also a smaller Fresnel zone, which we'll talk about because of 5 gigahertz. So you actually wind up having better bridging with 5 gigahertz.
And a different frequency.
The main thing is because 2.4 is so saturated, you want to leave what left of 2.4 there is. You only really have 3 non-overlapping channels. Use that for your client access because you don't want to create even more, use up another channel on 2.4. That's just a no-no. I guess if you're in the middle of nowhere and if you happen to have the radios, sure, go for it. But if you're starting and doing a design for bridging, always use 5 gigahertz. Okay, so for outdoor, we're going to cover both as an outdoor device as an access point and kind of the best practices for that, and then also bridging because there's 2 different aspects of outdoor Wi-Fi. So as an access point, these rules are very similar to the indoor, okay? Meaning for 2.4 gigahertz with a 20 megahertz wide channel setting, you need to set your channels to 1, 6, or 11 only, okay? Don't deviate from that. And then you only have 3 channels, right? Then you got your 4th one, you have to channel reuse. That's what you got. For 5 gigahertz, we actually recommend, and this is, you could say this is a little controversial. Some people have different opinions on this, but we recommend using also 20 megahertz wide channel, unless there's very high bandwidth requirements. A narrower channel results in more reliable network and less interference, and also more reliable at distance. Remember, outdoor, you're trying to maximize usually coverage. It's not so much a capacity play a lot of times, unless you're doing like a rock concert. Most of this time, we're talking like RV parks and marinas and campgrounds. That's kind of, when you think of outdoor, that's where you're trying to get coverage more so than even capacity. So, and the channels to use. Okay, so kind of like indoor, Uni 1 and Uni 3, channels 36, 40, 44, 48, 149, 153, 157, 161. So 8, okay, 8 channels. Those are the non-DFS channels. And then I actually would recommend those because those are the client devices are connecting to those frequencies. We recommend that. Now power, this is largely debated, a lot of people would think, oh, that's such high power, that's way too high. For outdoor, roaming isn't really so much of a concern, okay? So in other words, you could kind of cause potentially what you call a sticky client issue with having power this high. but usually you're not, the campers or whatever you're doing, you're usually connected to one. And also most of the traffic in these applications are mostly downstream. So you could have asymmetrical power on your client and get away with it usually, because I mean, you're not going to be supporting, if you're supporting, let's say, voice or something, no, okay, then you got to turn power way down. Same with high density. Like an outdoor venue, sure, turn the power way down and actually have the APs lower and more obstructed on purpose, because you're supposed to, you're going to segment your coverage and limit the amount of users per AP. Totally different aspect in the design. Most outdoor is more about getting just coverage. So yes, have power up a little bit. You know, you could have a few more dB than the client devices are, like the mobile devices, and usually it still works okay. Okay, so people ask, this is just a slide showing about the channels. They're 20 megahertz or 22 megahertz wide, roughly, depending on, you know, if you're in BG mode or N. But meaning the spacing's 5 megahertz, meaning you have to space them 5 channels away before you don't overlap on each other. You can see the chart on the bottom. That's why we have only 1, 6, and 11. If you notice on 5 gigahertz, you have, let's say, channel 36. You are not allowed to go to channel 37 and 38, 39. You don't have a choice. It just goes to 40. I wish they would have done this for 2.4. Wish they would just have 1, 6, 11 in every product ever sold, and then you'd never use channels 2, 3, 4, 5, like we do with 5 gigahertz. But it's not an option. That's why. So okay, now this slide, talking about the channels, the 8. I mentioned it earlier. So you have, this is your whole 5 gigahertz band. I circled the ones for the for client access. Okay. So there'll be another slide again showing where I'm going to show it for the for bridging. So, and you say, well, there's only 8 channels, really? Well, with 20 megahertz wide, it works pretty well. Outdoors, I don't think a wider channel is a good idea. You know, wider channels don't propagate as well, but interference can be an issue, actually, potentially getting far networks away, interference. If you have an antenna or an AP mounted up high, you actually starts hearing things from quite far away.
Yeah.
Okay, so comparing indoor, so indoor was like 50 to 75 feet spacing between APs. Typical question. And I'm saying typical, it could vary, okay? So this is just, you still take this with a grain of salt. This is a typical number, about 150 to 200 feet of coverage. If you mount an AP 15 feet in the air. Now, if that's with an omnidirectional antenna, so the typical 5 dBi omnis, you're gonna get about that. You could go a little further, but if you want to go much further, look at a sector. Go with, like, we have a 19 dBi sector. That usually punches at least about twice as far or better in distance, but it is 120 degrees instead of 360. So, you know, so a sector could be used to go much further without having to, say, mount another pole for another. So you could save, in a sense, it could create certain areas of coverage, but it actually go further in that direction it's pointed. So that could be useful. Depending on the application, of course. So high density, same rules apply, right? It's less power and more APs and closer together. And sometimes even 2.4 radios disabled, because you got that channel reuse issue on 2.4, right? Channels 1, 6, 11, and then 1 again. But if you got channel 1 hearing another channel 1 AP too much, if they hear each other quite well, then 802.11 is a polite protocol. They purposely will take turns. They're nice to each other. The problem is what you're doing, though, is just sharing the bandwidth between 2 access points. You're not gaining anything. But with 5 gigahertz, you could actually start, you know, putting lots of APs on 20 megahertz channels and now most people now have pretty much dual band devices. You have band steering and move people to 5 gigahertz. And maybe start even using some of those DFS channels even for client access. Not all client devices support the DFS channels, and that's kind of the main reason why I was mentioning the 8 channels, because those are pretty much guaranteed to be used by any dual band device, those 5 gigahertz channels, but the DFS channels not so much. There's other issues of using DFS channels for client access, but I won't go into great detail today. So just stick to the 20 megahertz channel for 2.4, 20 for even 5. Ideal mounting height, 15 to 20 feet. Okay, so like an RV park, right? RVs are around 12 feet or 13 feet high. You want to be above those, but you don't want to mount it 50 feet in the air because then because Wi-Fi really doesn't propagate that far. Then you're further away from your clients. Also, there's this issue where you kind of got RF shadowing. The antennas kind of, even though they're on the vertical beam width, I call it like the Pac-Man's mouth, how wide he opens his mouth, is the vertical elevation of an antenna radiation pattern. You could actually overshoot your people below you.
Yeah.
So don't mount it. You could mount it probably 25, 30, but if I'm exaggerating, but really high, no, it's not going to work too well. You're going to be further from your clients. Now power, and then you could play with power, but don't use power as a way of making up for poor coverage though. Okay. In other words, if your signal's down and your client devices aren't connecting very well, you really should put another access point up. Little tidbit there on the bottom, when you're doing a bridge radio, you could turn, and you don't need, like, let's say your link's only a couple hundred feet. And we'll talk about this. You want your link to be around -40 to up to about -65 dBm. That's going to be a good quality signal, a lot of throughput there. If you got a -50 signal, but you got the power turned up, you could turn down the power on your radio, and it'll perform better. It actually cause less interference, even to adjacent radios. Let's say you have a pole with a bridge mounted on the same pole as an access point, you'll cause less self-interference. Even it's a thing that a lot of people overlook is the fact that you could be on an entirely different channel, and if you're close enough to another radio, you're going to still cause some interference to it. It's called radio, it's referred to as like a near-far problem. Okay, so bridging. Now we're talking about bridging versus access point. Before it was in access point mode. Now, if you're doing bridging, we usually recommend using the DFS channels. So
if you're able to use them.
If you're able to use them. Most of the time, unless you're near an airport or the channel's being used. Now, one of the things you always want to do is scan our AP scan feature, because that's the vantage point of it, of what it's hearing. Scan and see what's there. You might find that channel 100 is being used by someone else, and don't use that channel then. The other thing is also, if you're now, I say this with a grain of salt, if you really are in the middle of nowhere or somewhere where you have no other networks, can I use Uni 3? Yes, definitely. For bridging, yes, actually that's even kind of better, but you kind of want to leave those for client access, just like you would never use 2.4 gigahertz. It's kind of the same reason or logic behind it is use my DFS channels for bridging, use my non-DFS channels for client access.
Yes. Most of the time when I recommend DFS channels for deployment outdoors, it's you have to wait 24 to 72 hours of actual operation to see if there's any DFS event. Things could change, like airplane patterns could change, how they fly over the property. That obviously changes whether you have DFS or not. The most thing I see is false positives, which you have a large number of wireless bridges in DFS channels that are close to each other with high output power would cause a false positive.
Yeah, if you're really nearby another radio, it could trigger that.
Yeah.
If you mount, say, two bridges on the same pole and they're only a couple inches apart, that's too close to each other, even if they're entirely in different bands. Like you got one on channel 165, another one on channel 36. Let's say you're megahertz apart, hundreds of it's still so close that it gets misinterpreted. The interference gets triggered as a false DFS event or something. Weird stuff happens when you don't follow best practices.
It has to be, in order for FCC to be DFS certified, it has to be 98%. And it doesn't say 90% positive or false, just 98% you detect it. So that's the reason why you get them, because only 2%, yes.
Yeah.
Threshold.
All right, so some best practices. Okay, you always use 5 gigahertz for bridging. Okay, a good signal, -40 to -65. Okay, stronger than -40 is too strong. Okay, so if you're doing a link 100 feet across, you just can't run a wire. Turn down the power if it's -30. You're actually causing the front end of the radio to be saturated. Your throughput will actually go down a little bit. There's two ways you can do it. You could purposely misalign the antennas, or you could just turn down the power, or a combination of both, or whatever. Just get it so it's -40, or in between that sweet spot, -40, -50 is really the best. Do not use auto channel, auto power. Okay, so yeah, you gotta, our default is, unfortunately, it doesn't really matter. There's no perfect default auto channel, but our bridge mode default channel is 36. Not good to use that. You definitely don't want to use, 36 is the most commonly used 5 gigahertz channel. So we want to change that channel to like channel 100 or something, but do an AP scan, find out what else is out there first before choosing a channel, but then locking down the channel, picking a channel, keeping it fixed. And then the power, okay? Don't just leave it at auto power. Change it to whatever, between 11 up to whatever the power goes, 26, 27, whatever, accordingly. Use the DFS channels for bridging, unless you're near an airport or other reasons, or it's being used. Scan the networks again, yeah. Check to see if it's being used. Lock down the IP address. You can do DHCP, but usually what you do is you lock down the IP address to one of the IP addresses within the same subnet of the network that the bridges are on. You don't have to. They'll still work in WDS bridge mode. They'll actually still work even if but the thing is, what about accessing them for maintenance or logging into them, right? Usually that's the convenient part. You can do DHCP and then later on Fing them and find them that way using the Fing app or something. You could find which IP address your router had assigned to them, but then just keep in mind then it could change, right? Use 20 megahertz. You could do 40 and 80, but 20 is usually plenty of bandwidth. It's a myth that you think, those data rates you see hundreds and hundreds of megabits. Most of the time, extremely high throughput requirements are not needed. If, like, say for a camera, even a very high megapixel camera is only 10, 20, let's say megabits. That's still well within what a 20 megahertz channel can handle.
Even client access is the same.
Yeah, right. WDS bridge mode. So for the end products, you can do 4 MAC addresses to 1, right? And the AC bridges, any of them, like the end station AC, you can have up to 8. Okay, so you can do 8. Typically, we recommend 4 to 1. You could do I'm talking about point to multi-point bridging here. You can do up to 8, and depending on the application, you can certainly do 8. I've done 8, lots of them. Let's say if it's just a camera and it's only a 2 megapixel camera on the other side, you could get away with it. But don't forget, if you're using a directional, you might be limited by the point to multi-point because of the directionality of it. So you might be limited that way, but typically 4 to 1. If you're doing a firmware upgrade, don't do it over if it's bridged wirelessly to the other side, because if you have a trouble with it, then how are you gonna get to it? You're gonna have problems. You kind of should do it on site or just leave it alone. It's rare you really need firmware upgrades. With bridging, it works or it don't. There's usually not too much issues. It's running. Don't unnecessarily do a firmware upgrade unless there's problems. I think in networking in general, a general rule is don't upgrade. It's kind of funny when I was doing the Network Plus certification at CWNA. They say that in the certification, in the book, don't do a firmware update. Even it tells you that unless there's a reason. A lot of times,
yeah.
You don't have to, a security reason or whatever. But just because it's there and you want to click on it, if everything's working, leave it alone. If it ain't broke, don't fix it. There's a setting for distance, and this a lot of times people do this wrong. They think the default's 1 kilometer. Okay, and you can set it up to 30 kilometers. That's the propagation delay time ACK delay, right? You have to you got radio 1 talking to radio 2, and they're several miles apart. There's the radio wave has delay. It's the speed of light, but it's a few microseconds delay. So that's what you're setting. Don't change it, or you'll just cause the throughput to go way down, because then your ACK sequencing is off. I see people do this all the time. So let's say they got a half-mile link. They'll turn up to 30. Think it's like increasing its performance somehow. No, match it to the distance. Okay, don't change it unless it's going to match what the distance is. Security, WPA2 AES. Okay, there's no reason not to use this security nowadays. I don't know. I think our newer products, you can't even do web. WPA2 TKIP or AES, don't even use that. Just do WPA2 AES. It's secure. Any of those issues with WPA2 AES have been pretty much patched now too. Was it a crack thing that came out? Yeah, that's taken care of. Mounting the bridges. If you're doing multiple bridges let's say on the same site, because you're doing, let's say, several directions or doing multiple links, or even a point-to-point hop, right? And you're on the building A to building B to building C, but building B's got 2 radios, one pointed west, one pointed east kind of thing. Separate them at least 1 meter. More is better, but at least 1 meter. And you can just do that. If it's on the same pole, just vertically separate them by about 1 meter. Also, of course, common sense is on the 5 gigahertz band, space them a lot on the frequency side. Space them, let's say if you're on channel 100, set the other one to channel 144 or even channel 165. Space them from a frequency perspective as well. Okay, when you're doing your mounting, mount them high up and where you can clear the Fresnel zone. Well, it becomes more of an issue at farther links. You know, at shorter links, you could even get away with going through a tree or something if it's up 100 feet. When you go further, it's less forgiving. The farther you go, the less forgiving it is. If you want to go several miles with an end station AC link, you got to definitely have clear line of sight. And clear line of sight meaning the Fresnel zone is clear, not visual line of sight. We'll cover what that is. Again, 1 meter separation if you have more than, and that could mean also an access point. If you're in an RV park and you're doing backhauling with a bridge, you want your other radio to be your other 5 gigahertz, you know, your dual band, you're at 2.45, your other one to be separated a few feet, about 1 meter apart, ideally. Of course, seal the antennas. The antenna is like an omnidirectional. Sealing those, adding a little silicone across the antenna port around the antenna is nice to do. Ethernet, seal that up. Ground the radio when applicable. If it's one of the radios that have grounding provisioning, ground it. Use quality STP outdoor rated Cat5 or Cat6 Ethernet cable. Okay, so the Fresnel zone. Okay, so it gets smaller as frequency increases. That's because the wavelength shortens as frequency increases. Frequency, the size of the wavelength is inversely proportional to frequency. So we did a little calculations for you guys. You can see 2.4, aside from it being useless for bridging because it's all being used up for client access and other interference devices such as Bluetooth and everything. The Fresnel zone is bigger. Now, can it still work if you have your Fresnel zone obstructed? Yes, at shorter distances, as I'm sure you've experienced. We've even done point-to-point bridges indoors through a couple walls, right? It was like you can get away with that. You can't run a wire. I remember we did a museum where they couldn't run to an access point cable. So they did an end station AC through like 2 walls. There's no Fresnel zone there, right? So, but it worked because it's short distance and it's only through a couple things. But realistically, this is you're doing your links. What the point is that, like, say you're doing an RV park or you're doing a camera. Just realize that ideally, especially as you go further, there is it's like a football shaped. It's not just visual. It widens as you go further, and it will degrade the signal somewhat. If your signal's -50, who cares? Don't worry about it if you're Fresnel zone. But if it's -76, sometimes maybe raising it a few more feet on each end can make a big difference, especially when it start really clearing that Fresnel zone. It makes a big difference in signal. But it also means that if you already cleared your Fresnel zone, raising it higher makes no difference. If you're up on a 100-foot tower and raise it to 120 feet, it makes no difference.
Yeah, it does. I've had an example where even short range, like at 300 feet, someone tried doing a camera and a remote access link, and they're going through a driveway of trees, and they're getting -80 on the link. So obviously they didn't want to trim the trees due to aesthetic measures, so they end up running a hardwire cable. But even that short run, the Fresnel zone played a part in that.
Yeah.
So it's, even though you may not experience or run into it very often, when you do, it's really matters.
Okay, so bridging an access point from the same device. Okay, so for example, our 620, ENS 620 is, it's got 2 radios. It's got a radio 1, it's a 2.4 radio, and radio 2 is a 5 gigahertz radio. The mode of operation is selectable actually on either band, but of course for 2.4, always set that to AP mode. The 5 gigahertz radio could be an AP mode, or it could be in WDS bridge mode and provided as a backhaul. And people do this. If you don't want a whole lot of throughput and you're giving up your 5 gigahertz radio for no longer client access, but for acting as a dedicated backhaul, that's okay. you can do that. And so that's an example. You will have to put the radio in standalone mode. Okay, so keep that in mind. Same rules apply. Now, keep in mind though also that these dual band radios are omnidirectional, right? So you're going to have lower gain antennas, which means your maximum distance is less. Generally speaking, less than 1,000 feet, assuming it's your obstructions are clear. You can point a directional antenna. Let's say you got an end station AC at the main building where your internet's coming in, and point it at the 620's Omni. Then you could increase the distance better than you would otherwise with two omnidirectionals. And the question comes up, okay, so you got two, let's say 19 dBi end stations. They can go several miles, up to about 4 or 5 miles. Now, if you go omni to directional, meaning let's say 5 dBi omni, 5 gigahertz, like the 620 antennas with a 19 dBi end station AC pointed at it, quarter mile, I'd say, even maybe a half mile if it's clear and you don't, your throughputs are going to start going down a little bit. But you can do that. To omnidirectionals, I've seen people try do this with like ENH 1750s. They'll have them both. Now these are omnidirectionals, both in WDS bridge mode talking to each other. I'd say probably less than, I'd go 500 feet or less typically for bridging. Okay, and then bridging an access point on the same pole, meaning two separate devices, like shown here in the picture. Okay, this is the recommended way. Okay, so in other words, you have a dedicated directional pointed back where you got a dedicated channel, a dedicated radio to provide the backhaul, and then you have provides a wired connection to the local access point on the same pole. So same rules apply. Try to make it clear for clear line of sight. Again, ultimately, it's your signal strength and signal to noise. If you've got a great signal, it doesn't really matter how. If it's a short distance, you can get away with having some things in the way a little bit. Let's see, space. Okay, yeah, the frequencies I wanted to cover. So in this example, it's in the end station AC set at the channel 165. The ENS 620 EXT and access point mode is set to channel 1 on 2.4 and channel 36 on 5 gigahertz. So this would be a recommended application design. This is the preferred way. You can get away with having dual band devices, 5 gigahertz radio as a backhaul as well. It's either or. Okay. Now we're going to cover the Easy Wi-Fi Planner.
Okay. So in this example, we're just using an RV park. So the client, this is an actual real customer too. The client had some fibers. So the main one was over on the left for the demarcation point. He wanted to run into all the access points. So if you look here, these are the wireless backhaul links, and they're going to go to access points. So if you come over to AP layout, these is what we recommend for the access point deployment due to his requirements. So some of them are able to be hardwired back, some of them were not. So the ones that are not able to be hardwired back, we actually do WDS bridges. As you say, these are end station ACs. You can see this is not an actual point-to-point, it's a point-to-multipoint, and it's kind of a little bit off, but it's close enough that it's actually able to actually get good signal and good performance there. And this one is too far from each other, so I had to create two actual units, 2 point-to-points, as opposed to 1 point-to-multipoint. This one you can see is 3-to-1, which is the ratio you recommend, 3-to-1, no more than 4-to-1. So this is how that works out here. They were actually using it for access for the TVs and you know, just the campers. They say the reporting back, they're saying they're pushing around 100 gigs a day. So it's pretty awesome. So that's why the 620 is a very good price point for a pretty good value for that. The end station ACs as well, which we have here. Sorry. There we go.
Thank you. Okay, so we're getting close to the end here. I'm going to do a quick thing here on tips. Okay, so some people even ask, what is a wireless bridge? It's basically a wireless wire. I just put a joke in there. The hard reset button's a hammer. I don't know why. I just thought that was funny, but it's not related. Okay, I just noticed that. Okay, so default IP address is 1.1 on pretty much all our devices, username and password, but change it, as admin, change it. WPA2 AES security, what's a good signal? -40, -65. Use 20 megahertz bandwidth. Use 5 gigahertz for backhaul or bridging. Which channels to use? I covered this. I kind of cover this all the time. I reiterate these. I constantly get these things. We're correcting the same things all the time. Less than 100 feet, turn down the power. We can go down to 11 dBm, turn it down. People leave it at auto. No, turn it down. Don't be afraid to turn it down. You're not hurting the performance. Actually, it's slightly better. I don't know if you know this, but if you look at our MCS rates, at maximum power, and this is true with any manufacturer, your MCS rates actually go down a little bit. At 26 dBm, your MCS rates are not at the top MCS rate. It's only at 22 or 21 or so, or even less. So it's a misnomer that you're going to turn up the power. Now at further distances, yes, sure, but at shorter distances, turn down the power is actually, and it's also good. You're just being a polite, in a sense, unlicensed user for 5 gigahertz. If other people do it, everybody, you benefit. It actually benefits yourself. Because then you have less interference to yourself.
Especially if you do a large deployment of these point-to-point, point-to-multipoint, you're going to raise the noise floors. You want to minimize how much you raise the noise.
The myth is that channel just magically just stops on, let's say if I'm on 50 megahertz and I go, 5140 to 5160, that's a 20 megahertz wide channel. Then that's all well, do you know that the sidebands are only they're only 28 dB weaker? That's not a lot. So in other words, if you're close by on a channel next to it, you're getting interference for sure. And so you get sideband interference. You also get, the raised noise floor scenario. So turn down the power unless it's needed. Now, if it's needed, just realize that you're causing more noise for everything around. And also the kind of the logic and reasoning behind directional antennas help reduce the noise in all of the other directions as well, except the direction you're pointing, or also what it hears, which is a benefit as well. Something comes up. We have legacy products or ones that are, let's say, N, and some that are AC, some are current. But when you're bridging, we see this from a technical support thing. You can't bridge, they used to say chipsets have chipsets only bridge to each other, because WDS bridge mode is a non-proprietary. It is a proprietary, I should say. It's not an 802.11 protocol, so it's not necessarily. If you have a different chipset, it may not work. Even in Genius itself, different models with different chipsets may or may not work exactly well, depending on what's going on. Although I'll say that pretty much they all work with each other. The only thing you got to really worry about is the mode of operation. If you have an ENH 500, it's an AN product only. It doesn't have AC. Just throttle down the more newer products that are AC capable. You're gonna have to throttle it down to the lowest common denominator model, meaning like in this example, the ENH 1750, you have to put it in AN mode. You have to, or it won't link in WDS bridge mode. So it'll work, but just realize that. But if you're doing, I would say if you're doing an ENH 1750, will work with an end station AC. That shouldn't be a problem. But the older ones that are N, that are a totally different chipset, throttle down the ACs. They should work with the N products in AN mode. Mounting higher is better for both bridging and for client access for outdoor most of the time. We've found people mounting them just like 10 feet high and raising it to 15 feet, like in an RV park, made a huge difference. A truck stop or something like that makes a big difference. The screenshot is one of the tools I wanted to just give you a tip is that's Insider by MetaGeek. So there's that they now just came out with it free. It used to be free forever, right? And then they started charging for it. Now they have a free version again, which is really cool. It just came out a few weeks ago. So MetaGeek has a free tool. See, it's really nice. You could see what's being used, and so I could see here right now. I could use channel 124, right? I see that as clear. So I could do, so it's a really nice tool. That's a recommended tool, and it's free. Now, this was the last webinar we did on best practices of the indoor. Now, I just wanted to point this out, this is still here, is that almost all the same things we did outdoor apply to indoor for when you have an access point mode. So a lot of the same stuff is here. I won't go into great detail now. I want to actually move on to getting to the next part, which will be the Q&A. So it gives more time for that.
All right, so let's see what we got going on the questions.
Yeah.
Is the EWS 660 AP the replacement for the previous ENS 1750?
I'd say pretty close. The big difference, of course, is EWS is manageable. They're very similar. You'll see they're as far as how they're made and stuff. So EWS is managed, the ENS is not. So yes, I would say if you're, the big advantage of anything with EWS part number is it could be managed by the local controller switch or EasyMaster. So going forward, that's what we're wanting to move all our products to, is stuff that can be managed.
What is the coverage distance between the end station AC versus the end station 5 AC?
Oh, good question. The same. It has a 19 dBi antenna, same antenna. They're very similar. The big difference was one is 24 volts and non-PoE pass-through, doesn't have PoE pass-through. Wave 2, but arguably I'd say the throughputs are very similar because the Wave 2 chipset in bridge mode doesn't make much difference. You're going to typically see a peak speeds of 450 megabits with either model. You know, the 867 is a theoretical data rate, but the real throughputs at a good signal and an 80 megahertz channel is like 400, 450 megabits of throughput with either model. Anything else you think of, Gabe, on that one? 24 volts on the end station 5 AC. What else? No PoE pass-through.
No PoE pass-through on the end station 5 AC.
Right.
But similar form factors, similar footprint, similar antenna, similar output gain.
Yeah.
So similar performance.
Yeah.
If I have multiple bridges mounted on one pole, is it okay to use adjacent DFS channels, or do I need to spread them out? I'm thinking in case of cross-channel interference.
Right. Yeah, you'd want to space them as much as you can. I mean, I don't know how many you had, but let's say you had 4. I mean, yeah, you go channel 100, even with a 20 megahertz channel, you wouldn't want to have 104. You'd want to go to 108 or more, 116, then 124. Space them more than, you know, that's what I would recommend. Don't forget, you got channel 165 also.
Is there an airport version of this webinar for setting up near/on an airport?
Oh, well, you know, the airport, we did a link of just, you know, you could, it doesn't, the DFS events, let's say, it's not the entire, usually channel 52 all the way to 144. You could turn it on, and what happens is it'll automatically force our radio to go to another channel. And if it forces it and it finds a channel that it doesn't pick up an event, it'll stay there. So it doesn't mean you're just completely unable to use the product at all. The other thing is you could also use the non-DFS channels. So channel 165, channel 149 through 161 could potentially be, depending on, especially if you have control of the network. If you have control of the network, meaning if you have access to limiting what channels are used by the airport itself, that might help too. I think that's what the question is regarding bridging. But if it's for access points, then you just use those 8 channels I recommend and reuse. That's the easiest, safest way to avoid having any issues.
On slide 20, there was a metal pole with the AP. Do the metal poles cause any issues for the AP or the bridges?
Yeah, that's a good point. It does, yeah, when you have an omnidirectional antenna and you have a metal right behind it, yeah, that's actually a good point. Yeah, I mean, you're gonna have a little bit of distortion of the radiation pattern. It won't be perfectly omnidirectional anymore, right? And, but for the most part, it's pretty forgiving. But yeah, I guess that's a good point. You know, if you're right behind metal like that and the antenna's right up against it, it will distort the omnidirectional radiation pattern a little bit. may not be ideal. In other words, if you really notice a big problem directly behind it or something, then mount it off to the side.
What is the name of the tool you mentioned again as a best practice to use?
One of them was the MetaGeek Insider. Insider, it's INSSIDER. It's a scanning tool. Now it doesn't do spectrum analysis. In other words, it doesn't do raw RF. It just does networks, okay? 802.11 signals, if you will, okay? So in other words, if it's some sort of, let's say, interferer like a microwave oven or a cordless phone or something that uses 2.4 gigahertz, it will not see that. That's where, and MetaGeek also sells them, is a spectrum analyzer, little USB dongle spectrum analyzer, which is also a very good useful tool. The Wi-Fi DBX is the dual band version that has 2.4 and 5, another great tool.
When you say seal the Ethernet port, how do you do that?
You can get that, what is that stuff, Kate? That nasty black, that tape stuff.
Masonic, they call it.
Oh, yeah. Yeah.
You could also do just like a silicone.
Yeah.
Flex seal.
Yeah, you can just use like a basic water, like a silicone type sealant, or that stuff, that nasty stuff, but that gets messy.
It does.
Can TV satellite be an issue, i.e. DirecTV or Dish, if AP or bridge is mounted too close?
A satellite is a receiver only, right? So if anything, you may cause interference, but you won't be getting interference.
I see Omni APs mounted vertically on a wall rather than horizontally on a ceiling. Is that okay to do? It seems that it would have negative effect on the range of the AP.
It has a reduction of the horizontal range. Yeah, the antennas in the AP, indoor AP, are pretty omnidirectional or like all directions. It does favor the horizontal plane. When you mount it on a ceiling, it'll go further out than it goes up and down. So yeah, if you mounted it vertically, it'll go up a little more than down. So if you're trying to penetrate a floor or go up, maybe you want to mount it vertically. Figure instead of going as far out, maybe that 50 to 75 feet, where you have to put another AP, you might go a little, maybe a 25% reduction in the horizontal reach out. It's not as much as you think. It still propagates pretty similarly. It's not a big difference in the coverage when you mount it vertically, but it is enough to be noticeable though. So yeah, I would just change the radiation pattern.
So we're running a little tight on time. So if you do have additional questions, please do not hesitate to email them over to us. A few things that I did want to mention, we will be emailing out the resources that we utilized today. So you will see the presentation. You will see those comparison chart tables to better understand the difference between our products and how they support the solutions that you're working towards. And then I also want to highlight the Easy Wi-Fi Planner. So you can definitely utilize the Easy Wi-Fi Planner with any of your design projects, as well as working with your dedicated sales team here at Ingenious, who can work with our engineers as well for some of those larger projects that you have, and maybe you have questions with the Easy Wi-Fi Planner. So we're definitely here to support you with your design projects. So if you do have anything, please let us know. And thank you guys so much for joining us today. Thanks.